Hello everybody and welcome to the part C of our video on section 18F about integrating functions of the form f of ax plus b. So we started looking at this example in our previous video. We did part A, now I'm looking at part B. In part B we need to take the integral of 2x minus 2 over 1 minus x. And first thing I can do is split this integral and take the integral of each function individually. That means I can pull out this common factor of 2, and here I can also pull out a common factor of 2. The other thing I can do is I can rewrite this part as negative x plus 1, just to keep it in that form of ax plus b, so we can see what that coefficient of x is. You don't have to do that if you don't like to. So as I'm working my way across, if I take the integral of x, remember that that is x squared. If I want to end up with x as my derivative, I'd have to multiply by I'd have to take the derivative of x squared, but I'd have to divide out the 2 that I would get. Here, I'm going to keep that 2 in front. To end up with 1 over negative x plus 1, I'd have to take the ln of negative x plus 1, and then I would have to divide out that negative 1 factor from taking the derivative of the inside part. Okay? I include my plus c, and I include a restriction because I can't take the ln of a negative number. So I end up with, when I tidy this up, x squared plus this negative and this negative give me a positive 2 ln 1 minus x plus c. If I want to figure out what that c is, I'm told that f at negative 1 is 3. So if this is f of x, I can plug in negative 1 for x, and this whole thing should be equal to 3. So I can isolate for c, and it's okay to leave this in this form, 2 ln 2, instead of getting a decimal. We prefer this exact form. So I end up with f of x equals x squared plus 2 ln of 1 minus x plus 2 minus 2 ln 2. That is kind of complicated, but that's how it's done. My computer's a little slow today. Okay. And last, we're going to look at example C. Same question, example C. Okay. If a curve has a gradient function that is given by this and passes through this point, find the equation of the function. So this is the exact same idea as the previous two parts to this example, except they use the term gradient function, which suggests that this is the derivative, and they gave us a point, which just tells us that f at 1 equals 0. So they're just putting it in context. Otherwise, I'm going to do the same steps. I'm going to take the integral of this function. I'm going to start by splitting the integral, bringing out any common factors. I'm going to apply my power law here. So I'm going to add 1 to the exponent and multiply by 1 over the exponent plus 1. And here I'm going to apply my exponential function law. So I'm going to remember that I take the derivative of e to the negative 4x. That's the same thing, e to the negative 4x, but I have to divide out that negative 4. Tidying up, I get this expression. Don't forget your plus c. And we're told that this function goes through the point 1, 0, which means that when I plug in 1 for x, the whole thing should be equal to 0. So simplifying, I get 2/3 minus 1/8 e to the negative 4 plus c. And if I isolate for c, I get this expression. Again, there's no need to plug this into your calculator or simplify. It's okay to leave this as your constant. Nevertheless, we end up with this function, which is the exact function that differentiates to give you this curve that goes through this point. Thank you, and we will continue in our last video for this section.